are 5 parties in conference, including you. Mute on.
I do not. I'm here. I brought my own device up. Yeah. Sorry about that.
You know if this is the pass?
It could be.
Okay.
Doesn't hurt to try it out.
All right. I'm going to try. I was downloading a bunch of cases today, and I had all the blog content. I'm the one who's supposed to. Yeah, I realized I wasn't hit the button. I'm the one who's supposed to. You're 20. You're not even. Okay, sure thing. Do that. Yeah, I had. You gotta do your best.
Yeah, that's probably going to take that train. I have not shared. I'm just going to go ahead and share my screen.
Okay, perfect. All right. Sorry about all the beeps, but we can't do anything about it. You almost ready? Yeah. Are you in presenter mode?
I am in presenter mode.
Can you do it without being in presenter
Oh,
mode?
yes.
Because you know why?
Yeah, because then, do you know how? I don't.
Yeah, I know how. This is PowerPoint, right?
Yes.
All right, let's end this slide. Let's see. I don't want to stop sharing. Where's that? It is in, is it in view? Oh, it's here, slideshow. We don't want the presenter view.
Okay.
I know, it's really weird.
Fantastic.
There
No,
we go.
that's good to know in the future. Thanks.
Yeah. Oh, that's kind of weird. And then, perfect. Thank you. I can tell later.
Are we good to go?
You can speak into the phone and this microphone.
Test, test. Okay, we're good to go.
Awesome. Sure. Ready? Okay. All right, well, thank you all very much for coming, and also those that are joining on the phone for this WSS seminar, where we're going to be learning more about combining GIS statistics data. But first, I just have a couple announcements. So if you're a member of the WSS or the ASA, like to join the Washington Statistical Society or the American Statistical Association, there are forms on the back chairs at all of the different doors. So if you are not a member of either and you want to sign up for both, you just need the ASA sheet. And there's also then one for WSS you have to sign up for. Also, we are still looking for some judges for the statistics the statistics posters for the science fairs that are coming up. So we have those in Virginia and in Maryland and in DC. So there's information on the back chairs as well. Our next education seminar is going to be on the 2020 census. That is on April 1st. Information 2 on the back chairs. And if you haven't yet, please make sure you sign in on the other back chairs by the doors. After this talk, we will have a reception where you can get your own drink over at the East Street Cafe. So to get there, enter Union Station by the door that's opposite BLS. You go up the escalator, turn right, up the next escalator. That escalator is not working, so if you do need an escalator, Carol will show you then where to go. And then, and there's also the elevator there. So then it's up the escalator to the mezzanine, and then pretty much all the way to the back of the mezzanine, and it's across from Uno's. So down past Uno's, sorry. So please feel free to join us for a drink or some delicious Asian food. All right, so that's all of my announcements. So now I would like to introduce our speaker. So here we have Lou Zhang, who is, he works for the Environmental Systems Research Institute, or ESRI, as part of the Science and Civilian Solution Engineers. So they focus on bringing GIS solutions to national governments that's spanning across multiple organizations. These include NASA, NOAA, the EPA, the USDA, Census, and Bureau of Labor Statistics. So Lou recently graduated in spring of 2018 from the University of Maryland, where he studied GIS and atmospheric science. So I guess, Lou, please enlighten us about combining GIS and statistics.
Thanks for the introduction. Good afternoon, everyone. So my name is Lou. So just out of curiosity, who has a GIS background or has played around with GIS before? Oh, that's pretty good. Nice. And I'm assuming most of y'all also has a statistical background, right? So when you combine GIS and statistics, you can get better insights, and you can easily communicate those findings to make better decisions. So, like I said, this is a pretty ad hoc presentation for me. I think my colleague Kristen should be presenting for the second half. So, if you see someone frantically running into the room, that's probably Kristen right there. So, I'm going to start off with just what is spatial statistics. So, some of the more general slides. Then I'm going to move on to how our software open source libraries within Python are, so you can kind of expand your spatial analysis. And lastly, Kristen will probably take over and kind of talk about some of the out-of-the-box tools that are within a GIS. So let's get started. So everything happens, but everything happens somewhere. Almost every action that's part of your life has a spatial attribute to it. And this is important because if a new Dunkin' Donuts is opening, I'm excited if it's right across the street, but if it's somewhere in California, I don't really care, right? So that's why the spatial attribute is so important. And by using spatial attribute, we can combine that with spatial statistics and techniques to derive more information out of our data. So what is spatial statistics? Here is the Webster's definition for spatial statistics. As you can see, it's spatial distribution, modeling, patterns, and all this other jargon. However, we broke it down into a few keywords, such as area, proximity. So when they're building the purple line, how's the proximity related to the environmental or the noise level of the surrounding neighborhoods? I took the metro in today, so I'm worried about orientation, direction. I hope they're not single tracking on my way back. So it's all spatial attributes is everywhere, and this is why it's important. So, us humans, we're naturally good at detecting spatial patterns. It's everywhere. Even a 5- or 6-year-old can expertly detect this. So I'm thinking, when you wake up at night and flip the pillow on the cooler side, you're kind of thinking spatially, right? And sometimes, and for better or worse, we think spatially too much. We're so good at detecting patterns that we detect patterns that don't even exist. So this is why we need to actually attribute statistical techniques to kind of make our data more authoritative. So is spreadsheets data or information? So this is a spreadsheet of the vacancy points in Baltimore. If I told you to present something to the Baltimore City Council, can you derive intrinsic value from the spreadsheet? Probably not, right? So that's why. So when you look at a spreadsheet, you ask for more. So you want the mean, the standard deviations, the min and max. So ask you again, is point on a map data or information? It's sometimes, in most cases, it's just data, right? So if I gave you this map of all the point locations mapped in Baltimore, the vacancy data, you can't derive much out of this data. It looks like there's a lot of vacancies in Baltimore, but that's pretty much it, right? So as we do with spreadsheets, we can derive more information from our maps. We can make these hotspot analysis where you can derive statistically significant areas where it's just not random clusters. You can get directionality from these point locations, as well as other statistical techniques, including machine learning clustering, random forest classification, geographic weighted classification, and some of those tools and techniques we'll get into later on in this presentation. So, and this is spatial statistics working in real life and serving real organizations. So I'm just going to briefly go through this story map presentation. I think. Can everyone on the Zoom meeting see where the? Okay, let me just 1 second. I'm going to stop sharing that. All right. Oops. Oh, I think that's the. Hold on. Yes. So as you can see, I'm not really good with the browsers, but here is a real-life example of how cities are using spatial statistics to solve real-world problems. So Milwaukee, like any other big city, is kind of plagued with some problems, including poverty and social inequality. However, so for example, when you have these large interstate freeways, they kind of silo off cities and kind of choke them opportunities and wealth. So they're proposing the rails to trails where they're implementing and proposing new trails to kind of link those siloed neighborhoods in Milwaukee so they can experience economic, so they count factors such as traffic stress, other barriers, and they also account for, I think, accessibility and through all these spatial analysis. And lastly, they make a decision regarding the proposed routes. So, and that's just one example of how all these organizations, both government, academia, as well as private, are using spatial statistics to solve problems. So let me go back to the PowerPoint. So that's the general introduction. So now let's talk about GIS connections with open source libraries within Python and R. So So just a quick question. Who uses Python in this room? Okay, a few people. And who uses R? Oh, a few more people. Fantastic. So
Wait, who uses both?
Who uses both? Oh, nice. So let's talk about the Python ecosystem as it relates to spatial statistics. Within our software, we have these APIs and libraries that allow you to connect and directly enable these spatial statistics tools directly in a Python environment. So, and the good thing about this is that you can easily integrate your workflow with these exploratory data analysis libraries such as Pandas or NumPy, and you can do some really good and publication-worthy plotting using Seaborn or Matplotlib. And you can even do more advanced analyses using machine learning libraries such as looking at scikit-learn and TensorFlow. So let me just show you this example. And this is actually the example I showed from my previous meeting with the USDA about an hour ago. So let me move into a Jupyter Notebook environment. Is there like an easy way to switch?
Well, I think you can share your whole desktop.
Okay. I click share. Then. Tab. Alt. Shift.
Yeah, but that's
Okay.
I'm sorry. Did I mess you up? Okay. That's always weird
Yeah.
with technology, isn't it?
Yeah. Not very good.
Oh, okay, good. We're share.
I think.
Oh,
Okay.
look, oh, it says.
Oh, it's share application. Okay, I get it now. I understand. So.
Yeah, you might
okay.
be able. Yeah, and then it's here.
Okay,
and then
yeah.
you want the Jupyter Notebook?
No, it's Jupyter Notebooks in Chrome.
Oh.
It's fine.
Okay,
it's
you
good.
have it done. Okay. Because it's not showing up here.
Sorry, one second.
Python, bro.
Yeah, it's all Python. It's all.
I'm plugging in. Oh, sorry.
Oh,
Yeah,
perfect.
Okay.
Wow, Martha.
Yeah, it's showing up here too.
Thank you. So here's the example of a Jupyter Notebook that I ran in my previous meeting. So as you can see, you can enable all your spatial statistics tools, such as raster calculator. So I ingested some weather data, right, from the PRISM climate model. It's raster data. And I can easily use powerful spatial statistics tools to derive map algebra, convert that into a polygon feature, and import that into a cloud environment. And while I'm doing that, it's storing the data as a spatially enabled Pandas data frame. So for those of you that work in a Python environment in a Pandas library, you can easily perform exploratory data analysis and visualizations using the full capabilities of GIS and the Pandas library. So, correct, yes. And now it lets you integrate with your GIS workflow easier than ever. So,
Well, or if Lou could just repeat the question, that would be good.
yeah. So he asked if the spatially enabled data frame is similar to GeoPandas. It is because it adds the spatial data column into your existing data frame, and it is easier to integrate with the ArcGIS environment. So here is the final map. As you can see, let me turn on it builds the climate repository for me. So as I scroll through time, you can see the cold front propagate throughout the United States. So this was from that polar vortex. And you can enable widgets to easily filter and perform spatial statistics using your data. So you can select the time and the temperature. So that's just one example of how you can integrate your GIS workflows into Python. And now let me move into our environment. So share. So we also easily integrate into R and R Studio environment. So as you know, R is a widely used statistical programming language. It's open source and contains over 10,000 open source statistical libraries. And it really can help you expand your GIS workflow. So if you're working in our GIS environment, you can easily expand and develop your workflows using some of the more advanced statistical functionality within R. And if you're a data scientist or analyst, you can do vice versa. You can easily bridge your R data into R. So this is really cool. And let me just show you some of the examples we've done with R. So the first one is a story map presentation that shows you a case of the integration of the R-ArcGIS bridge. So by knowing existing locations of seagrass, as well as their ecological marine unit data. So as you can see, each EMU has all these fields regarding the various chemistry of our oceans. And by using this data, we can easily bridge that data into our environment by spatially aggregating areas, EMUs with seagrass locations. So as you can see, there will be additional columns added to these EMUs with seagrass that's either ones or zeros, so binary fields. So then we can use logistic regression within R to kind of model where seagrass locations are. So here's the output, the seagrass locations.
Oh, you can't see. Are you probably sharing?
You just reselect sharing Chrome.
Yes. Sorry about that. So here's an example of using both the functionality of R and ArcGIS to solve real-world problems. And you can kind of predict seagrass locations for the entire world because we do offer EMU data for the global oceans. So next, let me move into our studio environment. So you got this was a presentation I did earlier this year. So I work with a lot of scientific multi-dimensional data. So essentially these data sets are really hard to read. Some of them have this strange coordinate system. So why not use R to ingest the data, read that into as a raster? So why don't I just read in this netcdf file? It's a file that shows the global ice coverage for some year in 1980. So as you can see, it's really a complex file. It's a hierarchical file, and you can see the latitude and longitude are within the variable. So these files are really strange to read, and you can see the coordinate system. It's called the EZE coordinate system, so it's something I never heard of before, and something that most software can't read, so including some GIS systems. So why not read in R using its various libraries, and then you can kind of plot it. You can kind of change the coordinate system. Then I did an interpolation to extract the values within a raster data set, right? Then I can make a few plots if I need it using ggplot. Then lastly, I can write what I just created in ArcGIS into an R environment. So by using the ArcWrite functionality. And that's just one capability. And let me just show you another script. So if you want to first, actually, so let's move into a, so this is a desktop GIS environment. And what we started with is the vacancy rates in Baltimore, right? And how can we use this vacancy rate in Baltimore? It's kind of like, let's try to predict vacancy rates in Washington, D.C. using this data. So we can we can aggregate this data into the neighborhoods in Baltimore. Next, we can add some parameters that we can use to predict that might lead to vacancy rates, right? Such as unemployment rates or income. So you can see the various variables. And we offer over 600 variables that you can easily ingest and consume in your GIS. And once that's done, it spits out this attribute table of all the variables that I've chosen to enrich the data with, such as average household gross rent as a percentage of income, and so on and so forth. So we can bring this data into our RStudio environment. So let me switch back into RStudio. Okay, so, and all you have to do is load in the data using the arc open function. Next, you can calculate some general statistics and kind of make a correlation matrix. So let me go ahead and run this code. So now easily it's going to ingest my GIS data. And from this correlation matrix, you can kind of see which variables most likely contributes to the vacancy rate, including the educational attainment and the unemployment rate. So now we can use like packages such as Deepler to kind of clean up our data and to make new fields to kind of organize what is vacancy rate, what vacancy rate is alarming. So in this case, let me see if I can find my code. So I said if vacancy rate's greater than 10%, then that's concerning. If it's between 3 and 10%, then that's slightly concerned. And if it's less than 3%, that's kind of no concern. That's a good neighborhood, right? So we're assigning discrete values as a new field into our existing data frame. And then we can perform ordinal logistic regression. And some of you might have more complex models, so R really allows you to kind of calibrate your models and assign those hyperparameters to make sure that your model is valid. And after you run this model, you can easily push your data as an ArcGIS environment. So let's see the results that is on here. So let's
double check your share again.
Oh, I think it's sharing. Yeah, I think it's sharing. So let's zoom into DC. So here's the probability of neighborhoods that are concerning. So those vacancy rates greater than 10%. So you can see it's mostly Eastern Washington, D.C., always propagating all the way to Columbia Heights area. Then you can see the no concern. As you can see, it's the other side of D.C., east of Rock Creek Park, all the way down to DuPont and Capitol Hill. And as you expect, the slightly concerned is kind of in the middle, right, around Columbia Heights. And so that's some of the results. And let me go back to the PowerPoint. And switch it over to Kristen. Thank you.
How do you show variation of your estimate?
You can use
map.
There's built-in plotting tools. So he's asking, how do you show variation in your data or your? And our GIS Pro, we have continuously expanded our plotting and visualization capabilities straight from the source, straight in a desktop GIS environment. And for those advanced statistical plots, you can also customize your plots in R or Python environment. So
that's not helping. You showed a plot of estimates on a map. Showed a plot of estimates on the map. How can you show some measure of variation on that same map at the same time?
I can't answer that for you right now, but I can talk to you after and we can figure that out.
I know how to do it.
That was your question.
No, it's important.
Yeah, it is important.
All right. So far we've done a lot of model building and a lot of sort of data diving. And, okay.
Well, I mean, we would be interested in talking with you and learning a little bit more about what your workflow and processes are, right? Because we speak to a lot of different organizations and agencies that benefit from knowing some of this. Though, you know, it may not be shown today, but it doesn't mean it's not possible. But you just mentioned that you do it. All right, guys. I apologize for my tardiness. As Lou is just coming from USDA, I was actually just coming from NASA. So here I am running in by the seat of my pants, going through the next presentation here. So Lou focused on a lot of the open source tools and integration with like Python and R, and then how that relates to ArcGIS and just GIS in general, right? So it doesn't have to be just ArcGIS. So I would advocate that that might be the only thing, since I am employed by Esri. But but it's just getting you spatially aware and thinking that there are attributes that lie underneath those X and Y, those addresses, right? So the next portion of the presentation is going to really focus on COTS tools. So that is commercial off the shelf. So what is available to you? And so why do I mention that to you guys? Is because a lot of the organizations and agencies already have existing enterprise license agreements, right? Or maybe your project or your group have access to software already that is not of an additional charge. So if you are, I know portions of BLS has ArcGIS deployed, you may be able to have access to different types of licenses, and these spatial statistics are available to you within and students. So students and faculty also have access to this. So we do have a college university program as well as a K-12 program that allows you free access to the software. You just have to know the right person to ask. A lot of the GIS community has access to ArcMap. Many of you might be familiar with that, more familiar with that, but also to Pro as well as to some of the online capabilities. And some of the tools that Lou showed was a story map, so a great interactive presentation that combines context, media, pictures, as well as your maps. So it's a lot better way sometimes to present information than PowerPoint, which we also default to oftentimes. So don't worry, from a organization agency standpoint, you might have an existing ELA, so you know, just talk to the right people. And if you don't know those right people, come up here and talk to us. We'll exchange business cards and we'll get you that right information. If you are a faculty or student, you may also have access to that software already. Again, you can come talk to us, send us an email or a chat, and then we can also figure out who that right person is to gain access to some of these tools here. So I'm going to be focusing on clustering, prediction, and classification. So what is the overall problem with maps? It's subjective, right? It's all in the eye of the beholder of what we want to communicate out to the public, internal or external here. So we're going back to this dots on a map. So this map, data, right? This map, still data. But where are the hot spots? Where is the variation greater amongst all of this? And that varies based off of what method you use. So taking a look at two different methods, natural breaks, quantile, equal interval, it all means something different to visualize those different types of variations as what you were alluding to earlier for your question here. So how do you make sense of all of that and turn that data into information? Well, you can use different types of tools to pull out that either space, time, location, look at large amounts of data, big data. From that complete spatial randomness, asking, is there a pattern? And so out of this, going back to what we saw from dots on a map into making information, can you guys start automatically creating clusters right now? Just looking at all of this? Maybe not. But using some tools, we can start digging a little bit deeper, addressing those issues underlying, and then figuring out, well, what are the chances that this is a cluster here? We all rely on those p-scores or p-values and z-scores. That's what tells you that difference. And by looking at this pretty nice arc over here, that middle section means that everything, there's no statistical significance. The red is there's a great significance, and the blue, that is the least significance, right? But it all means something. And we use that through a tool called hotspot analysis here. So it takes those different types of features, it sets weights to them, and it identifies those statistically significant hotspots. That one's a hard one. So how do we know that they're statistically significant? By tons of math, right? All of that's going on in the background, algorithms, mathematical equations. And another method, which is a little bit more headed towards the machine learning side of things, right? So you set your parameters. You say, well, this one is weighted more so than the bottom one here, and then you set those percentages of weights. So you're taking a look at the hierarchy there. Another way is the density-based clustering here. So it automatically finds those clusters based on those feature locations. So if we take, again, look at some of our points on the screen there, density-based clustering ultimately takes all of that information in, so you just set it as input file, and then it separates from sparse noise to what is significant. There are 3 different types: dbScan, HDBScan, and optics. dbScan, you have to define that proximity. What is that distance of significance from that single feature, right? So if I'm looking at traffic accidents, maybe I have to incorporate the length of the highway. Maybe I have to include the length of the road in DC, and that's going to vary from an urban environment, and then as you get further along into sparse towns. HDBScan is the most hands-off type of algorithm. You give it the data, and it automatically goes through and finds those clusters for you. You don't put in any type of values, any type of proximity values. It just says, from this feature, how close is this value? And it goes and calculates from each individual feature. And then it determines those clusters of what are significant. Optics is multi-scale. It's probably the most complex. It does have some defined parameters that you need to put in there, but you can adjust those parameters as needed. So it does require a little bit more of a hands-on approach. And I'm going to spare us the burden of going back and forth and sharing our screens here. But this is a story map of an analysis that was done, particularly for our FedGIS plenary side of things. We also do this type of analysis with Department of Transportation, taking a look at the amount of traffic accidents. So why are they occurring, where are they occurring, and how can we derive information from that? So how can we get value out of that? So if there's a particular stop sign or a particular three-way area where there may not be a field or anything like that, how can we inform those policy and those guidance areas to make better decisions, right? So that's ultimately what we want to get at, is taking all that data and that information and then make decisions off of that, right? But these are all hyperlinked, so you guys will be getting a PDF of the PowerPoint. I'll be sending that to Carol. Okay, well, make sure you give the email, or else you won't get the PDF and whatnot from this. But I will let you search that on your own time. There are tons of different story maps out there that go over our approach, as well as a lot of these spatial statistics tools, reference different articles of how we take a look at different theorems.
One thing, also the people who are remote. Also, the people who are remote, email C. Blumberg, and also, oh, you got a different way to do it? Okay.
Well, hi, Kristen.
Hi.
Nice to meet you. Okay, good. Hopefully there's no feedback.
Okay, so we'll figure this out later, but
Yep,
if it's
that's
okay if
totally
we
fine.
post them, on the WSS website for past. No, well, it's usually pretty quick, but, anyway, if that's okay with, Kristen, am I saying your name right?
Kristen, yes.
Kristen, okay, then, it'll be posted. But if you really need them fast, then send Carol an email.
Yep. She has my email, and we can. Yep. So there are ways for you to get this information.
The website is watchstat.org, but it may take a while for things to get posted. Sometimes it's quick, sometimes it's not. Depends on lots of circumstances. Same thing with the presentation.
Mhm.
You'll get a copy and then be able to approve it, and then it'll get posted. Maybe, but you're taking care of that part, not me. So,
There you go.
Okay, so when is it?
Okay, so moving on here. So we went over through clustering, right? But what about prediction? So I'm going to go and kind of combine the two categories, prediction and classifying. And how do we do that? Is through models, right? And that is how we generally go about the process and methods in which we go about doing our prediction and classification side of things. So why do we use models? Because we have questions like, which areas are most contaminated, what drives sales, things that we wouldn't inherently know just by like, okay, well, yeah, maybe the Potomac, right? We automatically know that that could be a contaminated area, but how do we make sense of that, and how can we derive predictions of, based off of these variables, where are other areas that could be affected, right? But sometimes we can't trust models, right, and that ends up being a huge issue because it takes a look at that noise. Right? And it starts generalizing a trend. So I'm not going to even say anything for this. I'm going to keep this up here, and you guys can make your own assumptions and based off of the correlations. So this is where models can go wrong. And this one I thought was even more interesting. And the last word is film. Right, so that correlation is pretty high. Well, there are many ways to model, right? So we have linear regression, GWR, so that geographically weighted regression, and then force-based classification and regression there. And we're going to go touch on each one of those here. So within that linear regression, there's three model types, the Gaussian, logistics, and Poisson. And then we typically call that the ordinary least squares. So what are we trying to predict or understand? And there we go. We have that math, again, trying to figure out that dependent variable, looking at all of the other complex math variables too. But we also have this exploratory regression. So that could be another term for that. It's all within that linear regression tools there. An exploratory regression, you give it a set of variables, so cultural, environmental, socioeconomic, and then based on running that through OLS, you test all of those different variable combinations, and you come out with a diagnostic report, or in this case, it could be right. So it's taking a look at the redundancy, the completeness, significance, bias, and performance of all of those different types of variables that you put into this particular model. GWR, so we're taking a look at that spatial variation here. So if we want to take a look at that center one, each feature gets a separate equation. So that long equation with the dependent variable there goes through each county, each district, each block, goes through and applies that equation to derive a value or a result there. And that's really looking at the R-squared, coefficients, residuals, conditional number, and predictions, ultimately making your predictions there. The last one to cover from a model standpoint, and this is where that classification piece comes in. And it tends to lean more towards that machine learning. We hear that buzzword. No, it's not anything new. And yes, many of you have already been doing all of that, but it's resurfacing. So we have to address it. So take puppies. Everybody loves puppies, and sorry for the cat people in the room. I have cats, and I have a dog. So if you want to take a look at all these variables, all of these breeds, the different variables, they have different size, color, fur, ears, age, weight, and we need to create a training set first. So then within this training set, it goes through this decision tree process, right? So what does, is it a big dog? Is it a small dog? What colors are the dog? What type of ears? Do they have droopy ears, pointy ears? And then that decision tree breaks into multiple decision trees, right, based off of your training data set. So you're going through and saying, okay, well, this dog has black, and you could do this from a vector data, but you could also do it from a raster data set as well. So you can think of like land cover classification or detecting different types of building footprints or pools and whatnot here. It also goes through and uses that same model, an algorithm in the background there. But it produces a random subset of data and variables for each of those trees. And then finally, we get to majority vote wins, right? So where are those potential applications and where it's being used today? So we have crop yield here. And don't worry, I gave credit where credit is due. These folks out in Stanford University are doing awesome things with respect to crop yield and predicting all of that there. Housing values, so we saw some of the home vacancy rates from Lou, but it could be used, all of the clustering, the prediction, the classification can be used in these areas. And what we are seeing at meeting with our end users and collaborating on different projects, these are areas that we're working in collaboration with them on. And then lead poisoning, right? So think of Flint, Michigan. So if I have lead results from Lou, your notifications. If I have blood test results from lead poisoning amongst all the children, can I predict where other children based off of parcels that could be affected as well, right? So I'm thinking of that cholera. Way back when you start learning about geography and how GIS and location matters, that cholera story there. So which wells have the cholera? All right, so we did all of this analysis and we covered it quickly. We did Spatial Statistics 101 in probably about 45 minutes here. But none of that matters if you don't present it in the right way, right? So covering some of data visualization. So we're really focusing on converting those slow reasoning and tasks into fast perceptions, and how do we end up doing those things. So by looking at this chart, can you tell me which one of these numbers are larger? Nope, they're all the same size. They're all uniform. What about this? So we can obviously point out what's larger, but why is it significant? What is it actually telling me? There's no labels. There's no nothing to it. But if I highlight and enlarge, I can immediately say that is the largest number. And that's the message I want to convey, right? If I want to say that there's this many home vacancy rates, that message is more impactful than saying there's a lot of home vacancy rates. Well, where? So we all know there's good visualizations and there's bad visualizations. And I'm not trying to harp on anybody at all if you have an Apple phone, even though I'm an Android person. But this is an example of one of those, sad to say it, bad visualizations. Can anybody tell me why? Why is that bad? Okay, yep, that is the first. Okay, so, yes, the color scheme, everything. So this is actually illusion. So it's kind of to mislead you, right? So we see in the blue that there's 39%, and then Apple has 19.5%. So it seems, and in the legend, the blue and the green are right next to each other. So it makes it seem like they have the second most largest market share. But that's not true because the purple, 21.2%, actually has the second most market share. I'm curious what the other is, but most of all, what is the rim? Who has rim? What is
Mary.
Oh, man.
Everyone's not even on this.
Right. So visualizations matter. I mean, kudos to him because this really, it got his message across. People bought into all of that. But we use visualizations to support a lot of our spatial analysis. We can't do visualizations with having something visual right in front of our face, and we use that through various means. Distributions, frequency, categories, change over time, distance. But sometimes, and it's sad to say it, a map isn't enough. So when we look at this map, can we decipher anything? Like highs, lows, what is it actually telling me? No. Okay, well now I'm getting somewhere. So now I'm looking at the comparison of unemployment rate by state. But if we sort it, I can immediately say that Nevada has the highest unemployment rate. Right? In North Dakota, I mean, that's good for them. But what about the population? What is that ratio? So we can even do a deeper dive into that, too. So my key takeaways here. Something happens everywhere. Whether we realize it or not, we inherently think spatially. Where's my nearest Starbucks? I know I ask that every single morning, or where's my coffee? Because I have a 1.5-year-old, and fuel is my life, or coffee is my life. See? Sleep deprivation gets to you. But then you also have tools available to you, right? So check with your ELAs, whether it's with Esri, whether you're using ArcGIS, but check with some of your GIS excellence, like studios of excellence or centers of excellence, right? Maybe they can help point you in the right direction there. That really enhances your workflow. So instead of looking at that tabular data and numbers all day long, which all of us can hopefully agree is very time-consuming and your eyes go cross-eyed, yeah. And then lastly, data visualization. Good data visualization really drives your message, but also makes quick decisions there. So if you guys have any questions, Lou and I are here. We can answer them, but also if you guys don't feel free to, can't stick around, there is our personal emails right there, so please reach out to us. We'd be happy to chat. We honestly, like our thing is we're not here. We're not based off commission or anything like that. We're just here to advocate for GIS, and we would love to chat with you guys. And Lou?
I think my email is wrong. So if there's dot between the L and the Z, it actually goes to another employee.
Okay, don't email this L Zhang, all right? I'll send the correct PDF out with the right one. Or you might be able to, but you might not get your answer that you're looking for. So I appreciate your guys' time, and the floor is open for questions.
We'll read this later.
Okay, wonderful.
Hi. Great.
Yeah.
Great talk, by the way. And so I had a couple of questions. I might have missed something because I came a little late.
Okay, I have my answer for you.
Thank you. So specifically, when you started talking about the spatial map and you were talking about the weights that you put on it and looking at the normal distribution, are the weights to make the data normal, or how are the weights used?
So there are in case they can't hear on the phone, like about the weight. Okay, so I'm sorry. No, it's okay. Yeah, could you repeat the question one more time?
Sure.
Sorry.
So the question was on one of your plots, which I don't remember now which one, but one of the statistics plots, the spatial plots were values and z-scores and so on. You also mentioned how you used weights, and I was curious if the weights were used to actually, the objective of the weights were to make the data normal, or was there another reasoning, or was there another method of picking those weights?
So it could be both. So one of the, and I think you're referring to the exploratory regression side of things when we're looking at, the linear regression side of portion of the talk there. So you could do it one of two ways, right? So you could, it's in a way to normalize the data, but because if you know that what those differences are and what those rates are, you could set those significant values within the tool to say, okay, well, I need to normalize this data. Another way to do that is you could set the percentages based off of what you deem as important, right?
Sure.
So it's addressing those two.
So go back a couple of slides.
Okay. Oh, you're talking about the clustering portion?
Yeah.
Okay.
Yeah.
All right.
Because there were weights here. So there were weights there here that you had said there was weights, and I was curious because I remember there was a nice Gaussian distribution that you focused on too, and I'm just curious, again, were those weights to make it normal, or was there something else? You mentioned weights over here, so that's why it stuck to me. Sorry to pick the...
No, it's okay. The farthest slides back. Okay, so I don't think it's necessarily weighting within a clustering. So you can do that, but that, I wasn't necessarily talking weighting with z-scores and p-values. I was talking weighting more towards that linear regression side of things.
Sorry.
Yeah. Yeah, no worries.
I have a question online. So the question is, how do these methods account for the spatial associations? I'm not sure which method they were referring to, but that was the question.
Yeah, I'm not sure what the proper way to answer that question is, because there's a lot of different paths we can go down. But for the person who asked that, if you could send me an email or you could speak up or elaborate in the chat window, I'd be happy to help.
Well, and you did talk about that a little bit, I think, right, when you said that with some of the models you were building, it did account for the spatial variation and association.
Right. So, I mean, there is, so depending on what type of method that you're using, right, those spatial variations can tell a different story. So using your quantile, your equal interval, your natural Jinx method as well. So you can play around with a lot of those variations from that spatial distribution side of things. But that's not really telling you anything. So we all know that when we're dealing with some of the demographic data, one of the easiest variations to go towards is quantile, right? Because it starts normalizing and equally disperses things, right? But sometimes that's not really the way that we want to visualize. Like, what is that message that you're trying to actually get to? So sometimes using the hotspot analysis will get to where you want. But that is looking through space and time. So if you think about the 911 phone calls, crime, right? So where can you tell, or predict where crime is most likely to occur based off of the hotspots there? And that is going back to the nice Gaussian curve there that you see, where things are deemed normal, significant, or not significant, right?
So
Yeah, no problem.
One final question, especially with the exploratory regression, I understood about all the terms that you mentioned except when you talked about condition numbers. Can you just elaborate what you mean by condition numbers?
1 second here. Let's
Sure,
go
take
towards
your time.
that demo so that we have some reference and context.
I appreciate that. Thank you.
Go through regression and okay, so you're talking about so you're talking about the geographically weighted regression?
So what do you mean by condition?
So that is a very good question. I don't actually know the full answer to that because it's actually one of the outputs. So when you run the tool with exploratory regression, so it's actually a tool within the desktop application that you run through all of this. These end up being the 5 outputs that you get from that. I can't tell you the exact thing for the condition number, but I'd be happy to get you that answer. Yeah.
Thank you.
Oh, I'm sorry. Yeah, can I use mine?
Sure.
Okay. I have a mic. So so BLS has regional offices. So our regional office out in California, they said they have ArcGIS as well as Tableau.
Yep.
And they wanted to know what's the difference between them, maybe pros and cons. Why would you use one over the other? And we'll pass the mic.
Okay, so the question is, what is that difference between ArcGIS and some of the Tableau things? So it really is on what question you're trying to answer, right? With ArcGIS, there's a lot of different tools, and I think we've hit over 900 plus different types of tools. That is really the core value that we hold. Tableau is used for a lot of the business intelligence side of things. You can pull in a lot of the base maps within Tableau, but running a lot of those complex analyses, I'm not sure that you're fully going to get that capability within that.
Tableau, Tableau, you can't really integrate with Python or R or something.
I'm not, actually, I think that you can.
Yeah.
I think that you can integrate with Python, yeah.
Yeah, I'm sorry.
Sorry, so the question is, with Tableau, you can't really integrate with Python and R, and you can.
Okay.
So you can integrate with Python and R, and it does give you nice visualizations from bar charts and graphs and all of those different types of things. But what you have with Esri and ArcGIS is that you have a huge platform, so it's not just that Tableau integration, and I'm not knocking Tableau because they are good at what they do there. But you have access to a lot of the interactive presentations. So the analysis that you run is a quick share up to a server, a quick share up to your cloud environment, and then you just add your data into these templates and applications. There's no coding, there's no anything behind all of that information there. There is a tool that we have. It's called Insights for ArcGIS. I would say it's pretty similar to what Tableau has to offer as well. I think that's probably the most comparison, and whoever's online, that's probably what you guys were referring to. Again, it's the tight integration with a lot of the desktop tools, the online tools, story maps. There's dashboards. So I can even share a lot of demographic dashboards coming out of World Bank has produced a lot of those, looking at the GDPs and whatnot too. So I'd be more than happy to discuss that with you guys.
So my question was more related to what we covered earlier with R and Python integration. You showed a lot of how to ingest and process data, and then basically just spit it back out in some ArcGIS format. Is there a good R bridge or Python bridge or some kind of SDK to programmatically, put those layers into ArcGIS? And in particular, I'm interested in ways to interact with this story maps product that I've seen demoed a few times, but I've never actually put one together.
See if it's actually
your question, you're asking whether ArcGIS can automatically integrate with Python or not.
Well, can you control your ArcGIS project programmatically within an R or Python script at this layer?
Okay, so to answer this question, whether you can control your entire ArcGIS project, is that correct? By just simply using a Python or R script. And to answer that, you can do that using a Python through a Python script. So for example, you can leverage all of the geoprocessing tools found within desktop and online. And you can, so for example, if you're making maybe real-time calculations or interval calculations, you can put your Python script and contain the ArcGIS functions and put that in a cron job if you're in a Linux environment or what's the Windows equivalent task scheduler. So then your layers on the web become automatically updated. So the Jupyter notebook I showed you, that's supposed to, that's great. Daily climate weather, daily climate data, right? So if I put that, that should be put in the cron job to run execute every day to get the latest daily weather data. So, and that automatically gets pushed through the API to the web app. So that web app is automatically updated without anything.
So are you trying to automatically pull data layers within the desktop environment? Is that what you're?
I mean, I'm just curious what the various functionalities are.
Okay. Do you utilize the R bridge at all, or?
I haven't.
You haven't.
So that's kind of what I'm asking. What functionality is there to actually?
So the R bridge is a way to communicate between the two. So you're able to use those traditional ArcPy and Python tools, right, to call out to what ArcGIS tools, right? And you can utilize that in an R environment, but you can also create tools, GP services, and whatnot within a desktop environment. So say you have tools that you created in R, and you want to integrate that in a Python script, you can pull that into your desktop and then have access to it. Same like you would as a model builder tool. You share a model builder tool, you pull that in, you can have access to it. The way that you would do that to have the two talk to each other is by using the bridge. And if you do have ArcMap, doesn't work so well with ArcMap, sorry guys, but the Pro has that inherently. So if, and I have here on my screen is ArcGIS Pro. So if you go to your, and just for those who are deep diving into this, so this is ArcGIS Pro. How many of you guys use ArcGIS Pro at all? A little bit? Okay. So it's a sister application to ArcMap, but it has a lot of the same functionalities and whatnot as ArcMap does. But what has changed is the UI UX. So you can see that there is a ribbon tab. You have a lot of your different types of your inserts, new map layouts, and if you are working in ArcMap, that's okay because you can import your MXDs into Pro here. A lot of your analysis tools, and so so if you go into your typical geoprocessing toolboxes, you can either create your own toolbox there, or you can view that in your catalog pane. So automatically toolbox gets added, and if you have anything in here, you can add in your Python and your scripts and your R in there. The way that you would connect and make those work is if you go to your options and then go down to your geoprocessing, you see that there's a lot of different environments that you can check on and off. But for those who are working in ArcMap and are working on a different version of Python, you can automatically say, well, I need you to check my code to make sure everything is A-OK, and then tell me what line of code is incorrect so I can make it compatible to work within Pro. On the bottom here is the ArcGIS support. So you would import all of your R home directories, and then you install this ArcGIS binding version. Everything is out on GitHub. We put all that out there, so it's really easy to kind of scrape all of that and utilize within the desktop. So, any other questions with R and Python? And any other questions with clustering, prediction, classification, data visualizations?
Still connected to that?
Yes. We connect to SAS, Oracle, SAP. If you're using big data, you can connect to Kafka, Hadoop, so, like all of those different types of things. We could get down on the weeds to what database that is best for here, but I wouldn't get caught up on what database is that is supported, because we're database agnostic. It doesn't matter what database. Now, how easy it is to connect into the database is a completely different question. Yep. All right, guys, thank you so much for your time. I really appreciate it. Thank you for inviting me to talk, and I hope to come back again. All right.
I think we had like 80 people online.
Oh, that's awesome.
Wait a minute, there's a little more.
There's a little more. Okay.
So, first I wanted to thank both you and Lou for coming and presenting for us.
Yeah.
So we have these lovely mugs for the Washington Statistical Society. So come on up, Lou.
Thank you so much.
One for you.
This is wonderful. Yeah. I'd also like to thank the BLS, Bureau of Labor Statistics, for hosting. And then finally, just another reminder that we are having the reception afterwards. If you would like to grab a drink with us or some food over at the East Street Cafe, that's just over in Union Station. So that is, let's see if I can get these directions down again. Enter Union Station by the door opposite BLS, up the escalator, turn right, up the next escalator, which is currently out of order, so you have to actually walk the stairs for that one. And then up the escalator to the mezzanine and walk almost all the way to the back. So it's then up on the mezzanine. So again, thank you both for coming. I like this. I can wear my nerd badge proud. That works.
Walk up the stairs. There is another elevator and an escalator, and I can take you to that.
Bye, guys. Thank you so much.
Thanks for your time.
Thanks. Okay. So how do we share? Stop sharing.